Oh, cool. This new stream manager interface is interesting for Twitch. Nice. Hey, Rapper, how are you? It's ironically over. All right. 1 minute to go. Hey, I'm Daniel. Mic check, audio check, video check. Check, 1, 2. How do we look? How do we sound? Hey, welcome to 270 Watch Party. Hello. Hello. Sounds good? All right. Audio is good. Video is good. It is interesting. Now I'm looking at, I have, hey, hold on for a second if you don't mind. Let me see if this works. Okay, someone. Hey, Virus. No voice. Okay. Can someone type something in the chat? I'm running multiple things, and the Twitch interface is a little bit different now for managing streams. Can someone type something in the chat? Okay. So I got it. So it looks like there's like a 30-second delay. Okay, good. All right, this is good. Yeah, the Twitch interface for managing stream is definitely, the stream manager is very different now. Okay. Hello, everyone. Hello. It's 4:30. Yeah, welcome. Yes, welcome to another episode of Introduction to Security at Tufts. I'm Ming Chow, Associate Teaching Professor at Tufts. Yes, hello. Well, I want to start off by saying that we only have 2 more episodes left, not including today. So after today, there will be only 2 episodes left. Yeah, the semester went by very quickly again. So next week, we're going to do forensics and a little bit of incident handling. That's going to be, we're going to talk about I'm going to show how do you recover files that were deleted or trashed by way of RM. And then the final course, the final episode is going to be on where do you go from here? What opportunities do you have? And the last week of the security class is always sobering. It's always very sobering. But today, one of my favorite topics, and a very relevant one because it's still going on today, is malware. Yep, malware. And it's that time of the year when we need to start to put everything together. We've had many fun weeks. So we started this course off with Linux commands. Then we had basic networking, attacking. Then we went to attacking networks. Then cryptography, including password cracking, vulnerability scanning, scanning in general. We talked a lot about web security, and it's now, and then of course last week we did static analysis, dynamic analysis, and really bad code. And now it's time to put it all together. Because you're going to need everything that you've learned for the last so many weeks into this topic of malware and malware analysis. Okay? So, before we begin, we got to get some preliminaries, definitions. Okay? So what is malware? Malware is a combination of 2 words, malicious software. Okay? Now, there are many different types of malware, And the way I tell people is think of organized crime. Think of different families. And there are many different families of malware. And each family is a little bit different than the others. And sadly, this also leads to a big problem with terminology because a lot of people use virus and worms interchangeably, and that is not true. Okay, that is absolutely not true. Today we're going to show, I'm going to do a demonstration of one, two, at least three types of malware. I'm going to do three types of malware. One is going to be a virus, one is going to be a backdoor, um, one is going to be a Trojan horse of some sort. Yeah, we're going to show that. Um, a zombie. A zombie is an infected or compromised computational device. That includes a PC, a phone, tablet, um, even a coffee maker, even a refrigerator that has a computer. Yeah. So have you ever gotten infected with a piece of malware ever, which most people have, you're a zombie. A botnet is a network of infected, compromised machine that can be used to perform attacks such as distributed denial of service. And so you can rent a botnet these days for like pennies on the dollar. Bot editor or botmaster is an attacker who controls the botnet, and CNC, command and control. Command and control, since CNC is an infrastructure, not just usually is a combination of servers and software to control malware in the botnet. This is extremely common in the world that we live in now, especially with ransomware. Now, this is just a really quick definition of like some of the real basic definition that you need to know from now moving forward. Um, I want to give a shout out to a friend, Malware Unicorn, Amanda Rousseau. Yeah, Amanda is a friend of ours for, I don't know, many years. She's hosted trainings. She's currently on the Morse team at Microsoft. And if you go to malwareunicorn.org, she provides many free workshops. And I'm going to show this again in the last week of class. Um, and she offers a number of workshops for free online. And her most famous workshop is Reverse Engineering 101. The workshop provides a fundamental to reverse engineering Windows malware using a hands-on experience with RE tools and techniques. So she goes through an introduction, what you do, what you need to learn. One thing that is really good with her training is it's concise, but it's also, well, for this course, a lot of the terminology that we have covered throughout this whole semester you'll see again. For example, um, reverse engineering is just breaking stuff, taking it apart. How you analyze malware and the analysis flow for malware, set up a baseline analysis environment, usually a series of virtual machines. Triage to determine a starting point. Static analysis is getting a sense where everything is before debugging. Dynamic analysis, as we talked about last class, is runtime, behaviors that cannot be understood by static analysis, and also there's manual debugging. Setting up the environment with virtual machine, portable executable, anatomy of a Windows portable executable format, a little bit about the x86 assembly language, and a typical attack flow. So this looks very, very familiar. This should look a lot familiar because it looks very eerily similar to the cyber kill chain. And this is one of my favorite parts of her workshop is the definition of the different malware classes. A virus, what a computer virus is code that replicates across systems with user intervention. It's no different than a biological virus. Think COVID, think the flu, think a cold. In order to infect someone with COVID, the flu, or the cold, you need to spread droplets, such as coughing on someone. Don't do that, folks. that does the spreading. And there is also a payload that does damage. And in the case of COVID, which is, it does a series of damage, including respiratory and cardiac damage. Okay? The way that a computer virus works the same way. There needs to be a way of spreading. And the way of spreading has to include some sort of a user intervention, like double clicking on a file, opening a file, going to a URL, opening up an email, some trigger action. And then the payload could be anything. Okay, the payload can be infecting, can be just as and seemingly innocuous, just open up a whole bunch of pop-ups, to even deleting boot sectors on a disk. Okay. Meanwhile, a computer worm is code that replicates across system. It just spreads without any user intervention. We'll get to that in a few moments. But let's talk about a computer virus. So let's give an example. Let me actually show you an example. We're going to do one out. I'm going to open up my terminal right now. I'm going to SSH into Kali, into my new home lab. Yes, I have a running lab now at home. Let's clear the screen. And I have a folder called Malware. Ooh, and the virus we're going to look at is foo virus. I'm going to remove all the .foo files. Okay, let's start from, I'm just going to remove this flower virus as well. So here we are. Now I have a folder with only one file, foovirus.pl. So what is a foo virus? In fact, I have a copy of it. Now you can take a look at on GitHub. git.github.com/m001. And here's a copy of the foo virus. Where is it? Right there. Created 6 years ago. And here's the foo virus. The foo virus was not written by me. It was written by Professor Avi Kak at Purdue University. And this virus was written in 2006. This virus was written in 2006. And it's also written in the Perl programming language. Now, the Perl programming language used to be super popular with system administrators and for people to write computer scripts. Okay? By the way, if you're listening on to this, I need someone to chime in. Someone just write something in the chat. And I need a few volunteers. No, I'm not going to have you install and run this, but I just need a few volunteers. So this is a foo virus. Okay? This virus, 37 lines long. It is 37 lines long. I'm going to paste this in the chat. Okay. "37 lines long. Now, just a warning for you. Perl is still around. Not as popular as back in like 20 years ago. Perl, I guess the best way to describe the Perl programming language, it's like the second coming of voodoo. It's not fun. You can write spaghetti code if you want really simply. But I'm actually going to just loosely explain how this foo virus actually works. All it's going to do, okay, first of all, prints out these following lines. The meat and potatoes of the code starts in line number 22. So what it's going to do, the first part, lines numbers 23 to 25, is just going to make a copy of itself. Get all 37 lines, make a copy of itself. Then what it's going to do is going to look for files that end in .foo in the current working directory. It's going to look for all the .foo files in the current working directory, read it in, plop a copy of itself, plop a copy of the virus into all 37 lines that you see here, into the .foo file, and then it comments out all the other lines. In addition, what it's also going to do is also going to make the file with file permission 777 read, write, execute across the board. Now this is what the foo virus does. Now, I'm going to do the demonstration of the foo virus. So more foo virus.pl. Yep, here it is, 37 lines, as you see here. There you go. All right. Hawk USAI. I'm going to use you as a volunteer first. So I'm going to do vim. So I'm going to create a file called hawkusai.foo. Thank you. Thank you. Thank you. Okay. So now I am going to do a vim. I'm going to create another .foo file. It's unironically over.foo. You played with great character. Yes. I do vim. Anyone else here? This place seems dead today. I'm going to do a vim. I'm going to do mdaniels.foo. Okay. Vim. I'm just going to make something up. And hey, Spass. All right, I think this is good. Okay, so what I have just done is I have created 1, 2, 3, 4, 5 files. hawkusai.foo, it's unironically over.foo, mdaniels.foo, vpoyakov.bar, oh, I forgot the A, sorry, and hasteblast.foo. Now, I'm going to clear the screen and watch what happens. I'm going to do an ls minus L. I want you to all, can you all see? I know the green is a little bit dark. Can you all see? Okay. Now, I want you to take a visual snapshot of this. Take a visual snapshot. How many files do you see here? Listed with ls minus L. 1, 2, 3, 4, 5. There's 6 files here. It's legible. But I want you to now also take a visual snapshot of a number of things. The file permissions, and also the file size. Bonus, the font and the font weight may also be affected. Okay? Oh boy. Can you all hear? Because actually it looks like my Wi-Fi just completely went out. This is strange. So, here we are. Can someone type something into the chat? Hmm. This is really messed up. Okay. So there are one, two, three, four foo files here. And there's one bar file. Yeah, I can see this. Hide my name. Thanks. Yeah, this is good. Yeah, because my Wi-Fi got shot on the iPad for some ungodly reason. I don't know why. That was really strange. Like really strange. Um, so I have haste blast. I have one, two, three, 4.foo files and 1.bar file. Notice the file size of each and every, and that makes sense. The file size for each and every file that I just created is pretty small. What I'm now going to do is I'm going to run the foo virus. So I do that by foovirus.pl /foovirus.pl. Watch what happens. Oh God. Permission denied. I hate you. Oh, that makes sense. That makes sense. I can't do it. I can do curl foovirus.pl. Hello from foovirus. This is a demonstration of how easy it is to write a self-replicating program. This virus will infect all files with names ending in .foo in the directory in which you execute an infected file. If you send an infected file to someone else and they execute it, their foo.foo file will also be damaged also. Note that this is a safe virus for educational purposes only since it does not carry a harmful payload. All it does is to print out this message and comment out code in the .foo files. Okay, that's nice. Okay, one other nice thing is that how old is this virus now? From 2006, 2016. It's almost 20 years old and it has stood the test of time. It's almost 17 years old now. I mean, I guess this is one of the nice things about Perl is that, hey, you write it once, it lasts for a long time. Hey, that's pretty good. Now, I'm going to do an ls minus l again. And does anyone notice something? Tell me what changed. Tell me what changed. Are there any changes? All the .foo files are much bigger. Also, all the .foo files, the file permissions are now read, write, execute across the board. Yes, and also the timestamp for each and every one of the .foo file also changed as well. Let's take a look at hasteblast.foo. Oh, fuck. How come that didn't get commented out? That's strange. Hoxai got commented. I don't know what the hell happened there. There it is. mdaniels.foo. That is so strange. Why did hasteblast.foo, the line did not get commented out? That's really strange. Anyway, oh, one more. All right. Okay. So now we have all the .foo files got infected with the foo virus. I'm not done yet. So congratulations, Vipolyakov is the .bar is the only file that did not get infected with the foo virus as intended. But now I'm going to create two additional foo files. go. I'm also going to create hide my name 999.foo. Now this time, I created 2 additional .foo files. Hide my name 99 999 and JK 2014.foo. Okay, nice. They have not been infected yet, but we have 4 other .foo files that have been infected. What I'm going to do now is I'm going to run huxusai.foo. Will this work? I'm going to hit the enter because huxusai.foo got infected. See what happens. Okay, this looks good. What happened by doing ls minus a now? Okay, so there's 2 things to be careful of here. Number 1, we ran huxusai.foo that was infected previously. So now huxusai.foo has spread to the additional .foo files, jk2014.foo and hide my name 999.foo. Okay, let's take a look. Hide my name. I know what you did last summer. There you go. We get JK 2014.foo. There you go. It works. Also, I want to take a look at mdaniels.foo. You take a look at mdaniels.foo now. Still infected. But also on a fine difference is it doesn't get infected again. So it gets infected once, can't get infected again. So, but that's very much like how a biological virus, let's say you currently have COVID or the flu or the cold, I mean, you can't get another cold or virus or flu while you're currently battling it. So it does not infect files that are already infected. Yeah, probably. It got to be some regular expression stuff. That's okay. Okay. But this is a great demonstration of how a virus actually works and spread. In this case, the payload is just printing out those bunch of lines. The spreading is just a for loop that actually goes to each and every .foo file, open it up, plop on the virus code, and then comment out all the other lines in the .foo file. And that's how it works. So this is an example of a virus. Okay? So that's a virus. That's a good example. Now, okay, but how does a worm work? Well, I'm going to gloss over why doesn't it comment out the for loop and add that in again? Why? Okay, so Radva said, why doesn't it comment the for loop and add that in again? Yeah, why doesn't it? Let's take a look. Okay, what's an if statement? Next, if all of it join. Oh, I think it's this join line that might have actually caused it. Next, if join all of it, maybe here. It just does a regular expression find. I think it's line number 30 and 34 that says, yeah, line number 30 is the one that rings a bell. That's the one that actually says, well, if it already exists, well, won't deal with it. Yeah. Okay. So what about a worm? Okay. A worm, yeah, a worm doesn't need to attach it to another, it's self-contained. Send copy it for itself over a network. So how do you do that? Well, you can do the dumbest thing possible. I mean, you can do this. Is just have a bunch of couple have a loop to every single IP address, like 0.0.0.0 to 255.255.255.255. So you can just do that. Or, well, you can do something that we've done already in this course, which is like do an Nmap scan. So worms actually can infect networks, like computer networks. So here's the thing, like how does a worm hop from machine to machine? Well, use commands such as like RSH, SSH, password cracking, sockets. We already know how to do that. Alright? Worm techniques. Does a lot of scanning, just select, or just, hey, even just do a lottery system and select random IP addresses. How a lot of worms used to work is it just, well, when it's on your computer, take a look at the host file that is on your system. Take a look at all the IP address and all the IP address in the host file, and just go through that. Worms do send small packets. Yes, now we know you have to know packets again to reduce suspicion. Connect to vulnerable services, exploit vulnerabilities. Hey, sometimes you don't even need. Sometimes all you just need is to walk in. A very good example is MongoDB. All you need to do, for the most part, is go to an IP address, go to port 27017. That's the MongoDB port. No username and password necessary for MongoDB servers. Connect, do whatever you want, and you can even open up shell. So the idea of a worm, actually, you already have all the tools and techniques to understand how worms work and spread on its own. It's a little bit of programming, and with a combination of techniques you've learned earlier, including like scanning and sending packets. Yeah. The most famous worm of them all is the Morris worm. Okay, the most famous worm of them all is the Morris worm. Robert Tappan Morris, PhD student at that was at Cornell, brought down the internet in 1988 with 99 lines of code. Well, the idea of Rob Morris's work was to connect to another computer, find a couple of vulnerabilities, and copy itself to that second computer. The problem with this code, the code that he wrote, was the original code and the copy would repeat in an infinite loop to other computers on the entire, well, it was an ARPANET. It also exploited a sendmail bug, used RSH and password cracking to break into other people's account. It would harvest address of other machines and the our host files in this case. It caused over 10 to $100 million worth of damage, 5,000 Unix machines affected. This was the first U.S. First conviction of the 1986 Computer Fraud and Abuse Act. Robert Morris was sentenced to probation, but there was a happy ending. And the happy ending is Rob Morris is now a full professor at MIT. He's been involved with quite a few Y Combinator ventures, so he does pretty well. If you want to talk about the Morris worm, I don't think you want to talk about it. So, there's also been a bunch of other famous worms out there. Code Red in 2001, and this just exploited a bug in Microsoft IIS web server. Just program. I mean, the idea is simple. Just program a random IP address for systems running IIS on the first day 1 to day 19 of the attack, just to face a whole bunch of websites that's attacked by Chinese. Did a denial of service attack after day 19, and the second wave affected 360,000 servers in 14 hours. Back in the early 2000s, this was a big deal. Okay, and then of course there was another infamous worm called Slammer in 2003. This was just random scanning. Affected most of the entire internet in 10 minutes. 75,000 hosts infected. Exploited a buffer overflow bug. And only machines running Microsoft SQL Server. Okay? So, I mean, the whole concept, you look back at it, was, yeah, these worms seem very rudimentary and they just work. Alright. So now I want to talk about my absolute favorite piece of malware because it is so dangerous. It is absolutely so dangerous. Now I want to ask you all a question. Okay, my absolute favorite is a backdoor. And you actually even hear backdoors in the news all the time still. The whole idea of a backdoor is not only bypass authentication, but bypasses all security mechanisms on a computer. Grants attacker access to a remote machine, and all you need to do is just connect to a remote machine using like Netcat or something. Um, Backdoors, I mean, think of it this way. You have a house. Anyone have a house with like a back door that comes into your house that goes into like a back door to your house? And what happens if you leave that open 24/7? What do you think happens? You open up a back door to your house and you leave that open 24/7. What do you think is going to happen? Anyone ever done that before? Leave their back door in their house open 24/7? A cat will come in, certainly bugs will come in, something is going to come in. Now, the worst thing is, you don't even know if it's a good cat or a bad cat. Furthermore, you don't even know if it's a good person, bad person, it doesn't matter. Neighborhood kid comes in and eat all your food. Yeah, that's it. Okay? This whole concept of backdoor is the same idea that the government actually advocate for. You know what? Law enforcement want a backdoor on every single iPhone. And this was a huge debate back in around 2018 after the San Bernardino incident. Okay, and where the FBI said we want to have a backdoor on every single iPhone, and Apple said no, because that backdoor that can be used by you, anyone else can use it, including criminals. Okay? Yeah, the neighborhood kids comes in and eat all your food. And the worst thing is, okay, maybe that's a good neighborhood kid that you've known for years. But maybe it's some rando that you really don't like. But it doesn't matter. It doesn't matter if it's a good neighborhood kid, bad neighborhood kid. It's just a neighborhood kid. Anyone can come in. Now, here's another fun question for each and every one of you. Let's see if how much you really remembered from this entire journey this semester. What has been a infamous port number that we have been using this entire semester? And I know we've been using this port number quite a bit. There's a certain port number that I use in packets. There you go. It's unironically over. Yeah. Ugh. Okay, so Van says 22 and 80. That's nice. That's nice. That's nice. Yes, we did have used that, but we've used 7777 quite a bit in this course. You may be wondering, remember 7777, port 7777? Especially we've done it a bunch of times. We've done it a bunch of times with demonstrations here. And you may be wondering, what's the significance of port 7777? Well, it's time for me to explain. And I want to do a demonstration of probably my absolute favorite piece of malware because it is so tiny and because the idea is so simple. And that piece of malware is called Tiny. Yeah, or Teeny. Tini. Yes. And this piece of malware was publicly available on the internet for years. And you know what? It still is. Take a look. I want to introduce you to Tiny. Hello? Tini. Tini. My absolute favorite malware. Teeny or Tiny is a very simple and very small backdoor for Windows, completely coded in assembler. It listens at TCP port 7777 and gives anyone who connects a remote prompt. That's all. All you need to do to run this piece of malware is to download the exe file and run it. Connect with an ordinary telnet client or similar to TCP port 7777 and press enter once. Now you see the command prompt and be able to type in command. In fact, the link I just provided, and this is from the Wayback Machine at Archive, can you still download Teeny? Oh yeah, look at that. You'll download it. But watch what happens when you try to download it. I'm going to save it to my desktop. Do you want to replace it? Cancel. No, but I want to say tiny-2. Watch what happens. Uh-oh. Uh-oh. Good at downloads, and something happened. This file contains a virus or malware. Archive.org. And you will have the chance, and now, if you don't know this, lots of web browsers, such as Firefox, Chrome, they have a built-in anti-malware engine now. All it is just a lookup table, really. Just a lookup table of known malware. You try to do this in Firefox, Chrome, any web browser these days is going to flag the download as malware. And so you have a choice. You can right-click it, you can say remove, you can actually allow the download or remove it from history or clear the download. I already downloaded it, I'm going to clear. Okay? Alright, just a warning. So for those of you who don't know now, a lot of modern web browsers have anti-malware built into it. Okay. Now before I give a demonstration of the Tiny, let's scan this using VirusTotal. Okay, go to virustotal.com. VirusTotal is one of my favorite tools. All you need to do is just a friendly reminder, VirusTotal, what it does is it analyzes suspicious files, domains, and IP addresses, and even URLs to detect malware and other breaches. And whenever you upload to VirusTotal, it gets shared with the security community. So be careful on what you upload. If you're going to be uploading confidential data from like government or like from work, not a good idea. Okay, because everything that you upload will be shared with the security community. VirusTotal is also owned by Google now. So what I'm going to do is I'm going to actually upload, the tiny.exe that I have downloaded already. I'm going to send it to VirusTotal for analysis. Watch what happens. Tiny.exe. Ooh. This ain't good. This ain't good. Anytime you see a number that's greater than 1, not good. This one is a very well-known piece of malware. 63 out of 72 security vendors flagged this file as malicious. You can see it's 3 kilobytes. Last modification, okay, someone worked on this 7 hours ago. Surprise, surprise. And take a look at all the security vendors and what they say about this tiny.exe file. Backdoor, Trojan, malicious, backdoor, Trojan. Hey, Microsoft, what does Microsoft call this? Backdoor. backdoor, Trojan. And of course, we have a select few security vendors who do not flag this at all, undetected. Not good. Go to details. You can see the basic properties of the piece of malware that we uploaded. You can see the MD5 SHA-1, SHA-256 checksum. You can see that this is a Windows 32 executable file type, backdoor. Port PE32 executable for Windows. File size is 3.0 kilobytes. Creation time was on September 5th of 2000. First seen in the first submission was in 2006. People have uploaded this file as a whole bunch of names, from teeny.exe, 724.exe, 824.exe. Uses kernel 32, wsock 32. Oh my god. Really? Even connect? No, that can't be right. Can't contact all these IP addresses. Okay, I find that shocking. Okay. So, behavior. Telemetry, community. What other people have called this thing? Alright, so VAN code. How does it infect a computer? Do you run it on a computer and then anyone can access it through a backdoor through the net? You got it. And now that you said to ask that question, VAN code, so how does it infect a computer? Do you run it on a computer and then anyone can access the backdoor through the net? You got it. Let me show you how it's done. Let me show you how it is done. And I'm going to open up VLC, my movie player. And I'm actually going to show you the video of how teeny or tiny actually works. Okay. So I'm going to hold on pause here. So I have, just to let you know about my testing environment here. I'll show you this video. I have a server. I had this home server back a while ago that just runs a whole bunch of virtual machines. I have a Kali Linux. I have a Windows 10 machine. I have a Windows 7 machine. See what happens. I'm going to open up Windows 7. So I'm going to have a Windows 7 machine running on my home, and I'm going to stop here. Notice I'm on a Mac OS. My terminal is a Mac OS. I'm going to run this video. There it is. Here's Windows 7. I'm going to pause here again. Just a friendly reminder, I have an instance of Windows 7 running as a virtual machine. I have a terminal on Mac OS running. So my main computer is just a Mac. But I got a Windows machine as a virtual machine running. Now, I'm going to open up Internet Explorer, our friend Internet Explorer, on Windows 7. And I'm going to download at a particular website what I think is a copy of Fortnite. Fortnite.exe. Which is really teeny.exe. Watch what happens. I'm going to go to this website, 34.74.110.173. Download Fortnite.zip. I'm going to save it to my desktop. Hit save. Stop. So I downloaded a zip of Fortnite.exe I saved to my desktop. Now I'm going to extract the zip file. Okay, the VM is running on the server. But watch what happened. Whoa, whoa, whoa. Okay, hold on. The VM is running on a server somewhere at my home. Good that you asked that question because you'll see in a few seconds. Hold on. So I'm going to do a CMD. I'm going to open up cmd.exe. Now you notice that I actually dragged and dropped a copy of the exe file to my desktop. Now what I'm going to do is I'm going to get the IP address. I'm going to get the IP address of the window, whatever this Windows 7 machine is. There it is. Okay, so the IP address of the Windows 7 machine is 192.168.1.205. 192.168.1.205. That is the IP address of the Windows 7 machine, virtual machine. Keep that in mind. That's very important. 192.168.1.205. Now what I'm going to do is I'm going to double click on Fortnite.exe. I just did that. Nothing happens. Nothing happens. Now I'm going to close. Now I'm on my Mac, and all I need to do is netcat 192.168.1.205 at port 7777. Watch what happens. Hit the enter once. Well, hit the enter again. I'm going to hit the enter key again, and watch what happens. I'm going to fire up the calc. That's the hacker way to show that you've broken into the machine. I'm also going to go to the desktop. I'm just going to create a text file on the desktop now. I'm just going to create a dummy.txt file stored right on the desktop. There you go. And that's the back door. Folks, that is a back door. Bypass a back door is just opening up a port number on the machine, and anyone with that IP, with their knowing your IP address, knowing the port number, all you just need to do is just netcat, telnet, whatever is your favorite program that you want to use. No need to do a login, no need to enter in username, password, none of that. And that is how deadly a backdoor is. Okay? A backdoor is just opening up, well, a backdoor for an attacker to get in. Basically, anyone, good, bad, ugly, your neighbor's kid. This is a good question. Tam White, that's a great question. Does this backdoor, is it persistent after reboot? And the answer is no. That's a really, really, really good question. The answer is no. Let's go back to the doc again. That is a really good question. So let's do. I can connect to port 7777, but nothing happened. You gotta press enter 1. How do you want to install Teeny? Just reboot Windows. Okay. Teeny does not install itself in any way. The only way that it is not persistent after reboot. The only way you could make it persistent after reboot is you set up a scheduling program, the scheduler on Windows. You add it to the scheduler saying on boot run teeny.exe or whatever the name of the exe file is. Okay. what's interesting is, why does my antivirus program say that there is a virus in Teeny? Probably because some antivirus program call all hacking to a backdoor Trojan viruses. There's no functionality in Teeny.exe except what is described here, and it's definitely not a virus. I would agree it's not a virus, but it's still malicious. Okay, so Tamwife's question, it is not persistent after reboot. But you may be wondering, is that true of all malware? No. A lot of malware are persistent after um, after reboot, especially when you deal with Android. Mm. Mm. So, let's talk about my friend Android. You know, the phone. And Android is a very good environment for malware. Android, for over a decade, has been ripe with malware. Loosely speaking, why? Well, the reason is because the police state actually works. For years, how Android has worked is anyone can build Android apps. Anyone can actually can actually download and push apps onto their phone using a USB cable. Mm. Android malware is one of my absolute favorites. Okay, so now on my desktop, so far you have seen teeny.exe. Now teeny.exe, anytime you see a .exe, is a Windows executable. I don't need this anymore. We don't need this anymore. But let's go to sample.zip. I have this Android app. I have an Android app here in sample.zip. Now, what happens if I upload sample.zip to virustotal.com? It may actually detect, okay, ooh, shit. 34 out of 65 security vendors flagged this as malicious. Trojan, Android, fake bank app, bank bot. What the hell? All right, let's unzip this thing. Now, first of all, let's unzip and let's see what we get. Okay, when we unzip it, we get an APK file. Now, let me upload this APK file and see what we get. I think we may get a higher end. Yeah, we got one higher. What the fuck? All right. So the first thing is, when you're analyzing malware, is a good idea and a very good thing is unzip a zip. If you get a zip file, unzip it first. Now, I'm actually analyzing directly on my Mac, which is not a good idea. In the real world, like reality, you should be using a virtual machine to analyze any malware. But because this is an Android app, and I don't have any Android underpinnings on my Mac, whatever, I'm safe. Okay, now wait a minute. So this is sample.apk file. Seems like this is a Trojan. 370 kilobytes big. But I also see facebook.apk. What? Spyware, and it goes by many different names. Trojan, iBanking, fake banker. What? Okay, so take a look at the screen, everyone. Trojan, banking, mobile spy. Anyone want to say anything else? SMS send, Anyone want to take a wild guess what this piece of malware is? Take a look at all the information. Take a wild guess from this result that you see right now in VirusTotal of the sample.apk that we're going to analyze. Keylogger. Anyone else want to say anything? Yep. Keylogger. Phishing. Yep. Anyone else? Spyware. All right. All right. Before we get to the details, let's do this. I'm going to get out of here. Close the terminal. I'm going to open it up again. Oh, CD desktop. I got sample.apk. ls minus L, 379 kilobytes. Not bad. What is an APK file? An APK file is APK is the Android, it stands for Android package. Very much like exe. If you see exe, it's an executable for Windows. You see an APK, it's the executable for Android OS. If you ever see .ipa, IPA is the executable format for iOS. Yeah, so now you know. An APK file, okay, is very, very similar to a zip file or a jar file, if you're familiar with Java. You can extract all the content. So if I do unzip sample.apk, it actually works. But it's not great either. So I'm going to do more Android manifest.xml. The Android manifest file, think of it this way, it's the bill of material for an Android app. It shows all the permissions, starting classes, what to run during boot time, you name it, list goes on. And if I actually do a more Android manifest.xml right now in the terminal, I'm going to get, it's all binary. Oh, God, that, no. See a problem? Not good. But let's go to RES, the resources and drawables. We'll come back to this later. But let's take a look at some of the pictures here. And this is a very important folder. I'm going to open up this. Let me just tell you, content in the RES folder, resources. This includes icons, pictures, assets, strings, you name it, that are for an app. And now we're getting a clue right now that from these pictures, look like this app is no bueno. Intercept SMS two-factor authentication. Wait a minute. I can tell you right now, you go to res, drawable, but can do, there's strings here, layout. Yeah, this is incomplete. This is an incomplete folder. Android manifest is binary. This is not good. Well, what I just did here earlier was I just unzipped sample.apk. But the problem is the entire app did not get deconstructed. The first thing that whenever you're analyzing APK files is you really want to take a look at the contents of the Android manifest file. But in this case, the Android manifest file is all in binary. So what do? Let's start over. Let's start over. Let's delete everything that we got here. The problem is, yes, you can unzip an APK file, but it doesn't deconstruct the entire app for you. It doesn't decompile the entire app. You need a better tool to work with. And I want to introduce you to APK Tool. apktool.org. APK Tool is free, it's open source, and it's also built in Java. APK Tool, what it does is for reverse engineering Android APK files. You can use APK Tool to disassemble an app, assemble an app, like lace like a legitimate version of an app like Instagram, lace it with your own crap, put it back together, upload, and then send it to someone, and also analyze. Okay? APK Tool, it's been many releases. Here it is. Hell, here it is. How APK Tool works. This is command line. It requires Java. And remember that Android manifest.xml was binary that we just saw when we just unzipped the APK file? APK Tool will actually decode the entire XML file and put it together, put it for you in a readable format, which is really nice. Now, I'm on Mac OS right now. Now, the first thing that you got to do before you install APK file, very important, very important. You need to install Java. And the way you install Java on Mac, probably the best way to install Java on a Mac, using Homebrew, is brew install OpenJDK. It's already installed. So I already have Java installed on this Mac as OpenJDK 21.0. Brew info OpenJDK. And what OpenJDK is the Java development kit for Mac OS. Well, in this case for Mac, for Homebrew. So the first thing that you got to do is, on any system, on a Mac, the best way to install Java is brew install OpenJDK. Okay? So make sure you install Java first, whether you're on Mac OS, whether you're on Windows, whether you are on Linux. On Windows, you just have to download the JDK from Oracle. To install APK Tool by way of Homebrew is brew install APK Tool. 2.9.3 already installed. Okay. So on my desktop right now, I have sample.apk. Yeah, there's still an open version of Java. I mean, the best one, I guess, is OpenJDK. I agree with APT student 04. I totally would agree because, yeah, let's not go on a rampage here. Okay? So now we have installed Java. You can test if you have Java installed. You can check if you have Java installed correctly if you do Java space minus minus version, and you can see I'm using OpenJDK 21.0.2. Okay. Now what I'm going to do is I'm going to run APK Tool without any command argument. Look at APK Tool, a tool for reverse engineering Android APK files. The minus, the capital lowercase d. Decode. Okay. Lowercase d stands for decode. I'm going to clear the screen now. APK tool d sample.apk. Watch what happens. Really quick. Load resource table, decoding file resources. Yes, it will put together, it will reverse engineer, or it will actually decompile all the Java classes into Smiley files. Look at the resource table, decoding Android manifest with resources. Okay, regular, oh, yada yada yada. All right, even will put, there it is, Android manifest.xml. The original, you have the resource folder now. Now notice that the resource folder is a little bit different because not only does it have the drawables, drawable will contain all the pictures, images, icon, yada 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 related to an app. Anyone want to take a wild guess language? What language this is? Mm-mm. It is check. Yeah. Yeah, Tam wife is correct. It's check. Yeah, you're all very close, very close. Great work. Yeah, it is check. Yeah, this is check. But what you also will see is a values folder. Values, like all the hard coded, all the strings that are in the app are in strings.xml. Well, let's take a look at the command line. CD sample. Now let's take a look at Android manifest.xml. Anyone ever use Android before? Anyone ever use the Google Play Store and downloaded an app? One of the things that you will see when you download apps on the Google Play Store is a list of all the permissions that the app will use, but hey, very few people actually care and read it. The permissions, that list of permissions is all generated. Yeah, exactly. So Tamwife noticed something right away. Tamwife mentioned that's a lot of permission. This app will have the ability to read your phone, call the phone, access the network, write to external network, read, write SMS, receive SMS, read contact, write contact, record audio. That's a lot of shit here. That's a lot of shit. You can see all the starting class. You can even see class name. What's com.soft360? What is that? Is that a phone number? Usually the permissions is a dead giveaway of how sketchy this app is. And as Tamwife just said flat out, hey, that's a lot of permission. Yeah, this doesn't look good. Okay? Let's go to the resource folder, res, and let's go to values, and let's go to strings. This app name, Facebook or OTP, one-time pad. No. Is it OTP stand for one-time pad? Yeah, one-time pad? No. One-time password. Oh, uh-huh. Fuck. This is not cool. Oh, what the hell? What the hell is all this? This is no bueno. That's a lot of strings here. Now, let's get out. The Smiley folder. What is Smiley? Okay. Smiley is a low-level programming language used to write Android application. It is a decompiled form of the Java bytecode that is executed by the Android runtime. So now you know. Think of Smiley as assembly. Okay? So think of it as assembly, but Java land. So you got a Smiley. Holy cow, there is tons and tons of Smiley folder files here. Let's go, what is this? What's this? A.1.smiley. It is. So, can anyone take a wild guess what you need to do to analyze this whole folder of Smiley code? What do you think you can do? What do you think you need to do? Now, are you going to go and look at each and every of these Smiley files individually? You can do that, but it's pretty dumb to do that. What's a better way? grep. You can do that. You can map to sources. But one of the things that you got to do, the first thing is look for URLs. Do a grep. We found one. What the f is this? bxateca.net iBanking crash log. What the hell is that? This is no bueno. iBank, so now we have Facebook one-time password, check language, iBanking. This is up to no good. What you want to do is, again, when you have some whole bunch of Smiley folder, just do grep like of certain keywords and HTTP and URLs. But in the interest of time, let's take a look at the details. I'm going to make a copy of this SHA-1. Facebook.apk, look at that. Package name. There's a lot of this. Yep, it's from check. Check. A lot of permissions. Interesting strings. Hey, you have a Twitter and LinkedIn. Yeah, we just found this iBanking one by way of grep. Alright, I'm just going to do a Google search for this hash. Oh, no. Let's do a Google search of this F44. See if we get anything interesting. Ah! Let's do malware. Found it. Facebook OTP.apk. Yeah, this looks like it's a idiots. Yeah, this is yeah, here it is. I'll go here. Go to github.com. Oh. And I got the malware from here. 8 years ago. Facebook OTP. There it is. What this piece of malware is, this is a fake Facebook one-time password generator that has the ability to read SMS, record audio and other stuff, send SMS. Oh yeah, not good. Not good. Yeah. Can I do a search of this string? Yeah, hybrid analysis. Oh, Android spy banker. Here it is. Yeah. So it's, yeah, that's not good. And now's your turn, the final lab of this course. You have an Android malware analysis lab. Basically, now I give you another APK file to analyze. Your turn now. Your turn to have fun. Yeah, all you need to do is download the APK file in a zip. Use APK tool. There it is. Spring 2024 example. We're out of time, folks. But now, yeah, that's malware. You got all the, there's six questions. Basically, the last lab is just do what we just did, but in a different APK file. Hey, folks, thanks for joining. That's all. I hope you had fun. And we'll do forensics next week. See ya.